Hello and welcome to this week's What Were They Thinking? Amongst this week's news items, we have yet more doctors receiving various charges for their COVID-19 related activities, largely activities that are not exactly conducive to being doctors. That cancer is getting better and that recent studies have shown a significant decline in the number of cases since 1991. The benefits, or in this case demerits, of circumcision and some bizarre studies into the effect it has on the various microbes that are around that area. The benefit of spending time in green spaces, but then at the same time, whether or not organic is really any better as far as food goes. The bizarre behaviour of yet another Australian animal, specifically echidnas, and a living solar cell. The timestamps for these and other news items can be found in the description box below. Starting with charges filed against a doctor for their COVID-19 misinformation or disinformation, depending on how you want to phrase these things. Dr. Ryan Cole has engaged in a lot of activities, and the source we have this from goes through a very long list of their behaviour. The biggest concern for us is the promotion of hydroxychloroquine, a medication that has been shown repeatedly to have no benefit against COVID-19. Another example of their behaviour that is highly questionable is that they involved themselves in the Died Suddenly documentary, if you wish to call it that, and that would be incredibly generous. They've also tried to lobby extensively to have this sort of behaviour not held to account, specifically to avoid accountability for things like prescribing ivermectin or hydroxychloroquine. The behaviours are rather obviously not good, and the fact that they do so and are trying to have no repercussions for doing it is a problem. Fortunately, that's not how the medical regulator sees their actions. Unfortunately, this is only the start, and they've basically been told these are the allegations that have been made and you will need to defend yourself. Going forwards, it'll be a case of whether or not they place more value in spouting insanity, or if they choose to actually try and defend themselves somehow, and not make things that much worse. There's a reason why we have medical improvements over time, and cancer, perhaps better than anything else, demonstrates this. Since 1991, the number of deaths from cancer has fallen by 33%. That is a huge improvement in roughly 30 years. The reason for this is very simple. We have better treatments established through proper development of drugs. We have better detection of cancer and better diagnoses of which cancers are occurring. That has allowed for more precise and effective treatment. The fact that we have observed a 1% improvement in mortality each year since 1991 means that, at least in theory going forwards, we should expect to see a significant improvement in the relatively near future for mortality. Now, we are never going to get to a 100% rate of people not dying. That's simply impossible. There are always going to be exceptions, outliers, etc. So the best you could ever possibly theoretically hope for would be 99.99%. But even that is overly optimistic. There are also other ways in which we've been able to reduce the number of people dying from cancer. And one of the biggest has been the HPV vaccine. The human papillomavirus, or HPV, has contributed to a huge number of cancers. Things like cervical cancer, penis cancer, throat cancer, the list could go on for a long way. But the reality is that there has been a massive drop in the number of those cancers, and this itself has contributed massively to that 33% reduction in mortality. Be aware though, mortality does not equal cure, and this is the key. People may not be dying from cancer, but they may not be completely cured of cancer. This means that they may be living and have a reasonable quality of life, but they also need to be on treatment basically for the rest of their life because you can't completely eradicate it. You might get rid of most of it, think they're in remission, stop treatment, and then the cancer comes back. This is the key here, and something to be very aware of when we talk about the reduction in mortality versus reduction in cancer. Conversely, where we see a decrease in the number of cancers related to HPV, we are seeing an increase in other cancers. For example, prostate cancer. So this is not a calculation where everything is going down. Rather, in some ways, we're seeing a rebalancing of the distribution, and that rebalancing can then lead to issues where some have gone down much more than others, and some have gone up somewhat. In other medical news, but this time looking at circumcision, a very small study has found that by having a child circumcised, that there is a significant change in the microbes that are in the area of the penis. Now, we specify this is a very small study, as it only involved 11 children. So yes, we are talking about a tiny study here, and really, other than the fact that it's truly bizarre, it really wouldn't be worth talking about given its size. Given that there is almost no research into this, the reality is that this 11 large study is basically the best we have to go on at the moment. What they found is that pretty much the bacteria that were involved with this were linked to inflammation and STIs, which is a worry given that these are children. The theory is that by removing or reducing the population of microbes that increase the risk, you are therefore going to make them less susceptible to an STI later in life. The study basically tried to find some sort of correlation, but as we have said before, and as is well often quipped, correlation does not equal causation. With that in mind, we move on to the next article, and specifically the link between coffee and reduced cardiovascular disease and mortality. Again, keeping in mind, correlation does not equal causation. So even though this has been found, it's also something that has not been established as a clear mechanism between the two. Admittedly, we, like many others, can have our blood type measured in the form of coffee we consume. In a more empirical description, we can tell you what they did. They broke down the consumption of coffee into different kinds available, whether it's decaffeinated, ground, or instant. They then divided them into the volume of coffee consumed a day between 0 and more than 5. They also compared them to non-coffee consumers. The study did have a relatively large cohort at 449,000 and some participants. The average age was about 58 years, and it was roughly 55% females. They were followed for approximately 12.5 years. This was also done all through the UK Biobank, so this is an important thing to note. The UK Biobank is a large dataset that is available. It is useful, and there's been a lot of research in the last year or so that we've spoken about that uses it. The results as far as consumption go was that the more coffee you consumed, the lowest risk you had, so long as it was ground coffee. If you consume 2 to 3 cups of coffee a day and it was instant coffee, you also had a lower risk. Admittedly, not as low, but still low enough. Now, this is the interesting thing. The biggest benefits were found for those who consumed caffeinated coffee, not necessarily decaffeinated coffee. But decaffeinated coffee did provide benefit. That would indicate a number of different possibilities. One is simply that caffeine itself provides some protection, but that something else in the coffee provides protection as well, which is why decaf has that benefit. It was noted that decaffeinated coffee did not provide benefits when it came to arrhythmia, but ground and instant coffee did. So, in summary, remember, correlation does not equal causation, and especially for these sorts of observational studies. It would be a nice justification for your coffee consumption habits, but it's not necessarily the case that you are actually getting more out of it. In other medical news, although this time shifting to the use of prescription drugs, it seems that the more time you spend in green spaces, the less likely you are to use prescription drugs, unlike the world's favourite drug, caffeine. This isn't necessarily anything fancy like having to go out hiking in the middle of nowhere. Regular parks and gardens can have the same effect apparently. Although this is a Finnish study, and how much sunlight and green space Finland actually has is a good question, given that they spend, at least part of the country, a significant portion of their year in complete darkness. Again, this is a sort of study where you do need to apply a liberal amount of salt to it, as not only is it a relatively small study using roughly 6,000 residents in Helsinki, a lot of it's also reported data from a questionnaire sent to the individuals involved. You need to be very cautious. This kind of study has well-established methodological flaws, which, whilst not able to be addressed necessarily without a lot more steps involved, do affect the outcome and how well you can extrapolate out. The gist of the research is that people were asked how much time they spent in either woodlands and similar environments, or somewhere where they classified as a green space, and those who spent them in a blue space, which is something like a lake, river, or ocean. They were then asked how much time they spent in these areas. The results were that between 3 and 4 visits a week led to a 33% lower probability of using something like mental health medication, for example, antidepressants. A 33% lower probability of using mental health medication, for example, antidepressants. 36% lower probability of using blood pressure medication, and 26% lower probability of using asthma medication. If you increase that to 5 visits a week, it dropped by a further 22%, 41%, and 24%. The key here is that they're not talking about causality here, just correlation. So, for example, if you are on antidepressants, the probability of you being willing and wanting to go outside and go through or to these areas is much lower. So, it's a question of which comes first. The depression leads to lower engagement with these areas, or being in these areas decreases the need for medication. Shifting to research that actually will give us some sort of idea about which comes first, is organic food better and safer? Well, we can answer the first question for you. No, it's not better. The reality is that the composition of organic food is really not that much different, if at all, to conventionally grown foods. You get exactly the same nutrients, vitamins, and minerals from them as you would from any other food, and you would be able to get more from conventional farming methods. The next question then is going to be, is it safer for you? And the safety question is a very big and very contentious issue. So we have previously explained that there are a range of issues around organic. And not only are there a range of issues around organic, but that the actual meaning of that word has nothing to do with how it is actually defined. Organic will vary hugely from jurisdiction to jurisdiction, where something in one area may not be allowed in another, and vice versa. The broadest accepted definition of organic is that it is food produced without the use of synthetic pesticides and fertilizers. Some people will add GMO to this, but yeah, no. They also, within the GMO category, carve out irradiated foods, for example, those that were grown years back using radiation gardens. As the article demonstrates, there are a wide number of claims from various, let's say, advocates of alternative lifestyles, most of whom are idiots, that really don't know what they're talking about. For example, no GMOs used. Is it allowed in organic and non-organic? Well, yes, it is used in both. What about synthetic pesticides? Well, yes, they're used in non-organic farming, but the pesticides that are used in organic farming are often just as bad, if not worse, and this is why the synthetic pesticides were developed. There's also no link between lymphoma and leukemia when looking at it over the long term with those who actually have exposure, notably farmers. You then have things like Roundup, the use of various residual material on there, the use of sewage materials, the use of growth promoting things, so for example hormones or antibiotics, and then similar sorts of things. None of this is accurate, and the claims made in the image shown are insane and absolutely wrong. There is actually something of an irony in that food from organic farms can and often does contain significantly more microbes. This is because they often use animal waste material in lieu of synthetic fertilizers. It makes sense that if you're going to put shit on a field, that there's a good chance the bacteria from that will find its way onto, or if not into, the food you're going to eat. There are other concerns, notably that, as mentioned, the kinds of pesticides and herbicides used in lieu of synthetic versions are much, much worse for you. And unfortunately, they do tend to be found on these foods. Germany and America in 2022 and 2021 both experienced outbreaks of E. coli poisoning related to exactly this. There's also the concern around just how much food can be made in the land available. The reality is that organic farming does have a lower yield per an acre than conventional farming. This means that no matter what you do, you are going to get less food and therefore be less sustainable. It's also going to increase the cost of the food that's being made. Moving on to other organic food news, and specifically American news, that the USDA, or United States Department of Agriculture, has given, or at least announced, new guidelines for labeling food as organic. In some respects, this is actually helpful, specifically because it removes a lot of the issues around what is and is not organic. For example, if you are to take organic as it's defined in chemistry, anything carbon-based is organic. This means the vast majority of chemicals used both in conventional and organic farming are organic. This is why these new guidelines are helpful. The organic label now has to meet certain criteria about soil quality, the practices used in animal raising, pest and weed control, and the use of additives. Unfortunately, given the vagaries of what organic is as a whole, we're left with problems because they're not using anything like the chemical definitions. Rather, they're using more descriptive and qualitative descriptions. This includes things like no toxic or persistent pesticides. Okay, but that would mean just about any pesticide, or herbicide for that matter, could not be used because by their very nature, they're meant to be toxic. This is a problem, and it highlights exactly why organic as a label is really not great. They require that no synthetic nitrogen fertilizers are used, that there are no antibiotics for livestock, that there are no hormones for livestock, that there are no GMOs used, and this is one that we have a problem with because GMOs are an increasingly necessary requirement, simply because you need to account for the changing environment across the world. That is, farmers in Africa need crops specific to their circumstances, like being drought resistant, whereas farmers in Louisiana might need something like more water resistant or mold resistant. Places like India are favoring BT cotton and eggplants so they can deal with the bugs and things that will eat their crops. Circumstances are hugely different and GMOs will help with that. Then there's the requirement that they don't use sewage. And finally, that food is not irradiated. Again, the issue here is highly questionable. So long as the radiation does not persist in the food, and you'd probably have more worries to do with bananas if that is the case, radiation isn't a sensible thing to exclude. It's going to remove risks of things like E. coli getting into and staying on food long after it's been removed from the farm. To some extent, this is closing some rather ridiculous loopholes in the organic labeling scheme, while on the other hand, it's just as self-defeating as organic was beforehand. In many respects, the nitrogen fertilizers that are used in farming, whether they are synthetically made or, for lack of a better way of phrasing it, naturally occurring, are exactly the same chemically. There is no difference between them except the synthetically made fertilizer is only the necessary nitrogen content. There is no other content in it. Makes it much easier to ensure that you're only using what is appropriate and at the appropriate level so you don't get nitrogen runoff. The naturally occurring options are full of things other than the nitrogen needed as a fertilizer, plus you have to use a lot more, leading to possible runoff. These are issues that could be avoided simply by having a consistent and reliable definition of what is organic and ensuring that it's actually understandable and not so vague as to be pointless. Going from organic news to GMO news, and specifically focusing on coffee, scientists have been able to successfully genetically modify a coffee plant to be able to produce coffee beans that do not have caffeine. Now, this is distinct from decaffeinated coffee, which is normally done chemically. That raises all sorts of issues for various people, but the simplest reality is that, for some, caffeine is simply not something they particularly want. The downside to doing it chemically is that it does alter the flavor, and notably so. By being able to make the coffee beans without having to chemically remove the caffeine from them, you do create a coffee bean that has all of the flavor and all of the desirability of a coffee bean, but none of the demerits. So, this is all sorts of weird and interesting. The catch to all of this is that whilst you'll get a coffee bean that doesn't have caffeine in it, the plant itself also isn't making any caffeine, and that's the issue. It's normally put into the leaves and bark and similar to act as a pesticide to keep away predators that would otherwise have eaten the coffee plant and therefore deprived us of sweet, sweet coffee. This has been the caveat with research into coffee beans and how to make them decaffeinated from the very start, and research is moving ever closer to being able to have caffeine in the rest of the plant but not the beans. Going to other news in the environment, but specifically weird Australian news about the echidna. The echidna is an Australian marsupial that likes to hide underground with its spike-covered body pointing outwards, so that it can't be eaten by any predators. By itself, it's not exactly weird, it's really no different than any other species in Australia in that they are bizarre, but at least this one's similar to other animals across the world. It does, however, have one truly bizarre behaviour that does make it stand out. Unlike other species, it can't sweat, it can't pant, and it can't lick itself. That's because of its body. It doesn't have sweat glands, it doesn't have a mouth that can really be used to pant, its tongue is really mostly used to get ants. It can't otherwise get itself wet in order to be able to get rid of heat, and in Australia, heat is a big concern. It deals with this through an ingenious but disgusting method. It blows wet bubbles out of its nose, and that allows it to cool itself. The research comes on the fact that they've observed echidnas sitting in areas where the temperature can be nearly as high as 50 degrees Celsius, or halfway to boiling water, yet the echidnas are 20 degrees lower than this, at 30 degrees Celsius, if not even lower again. The way it worked was that when they blew bubbles through their nose, the bubbles would burst near the end, covering their nose in moisture, and that this would then allow the moisture to evaporate off and cool them down. In other environmental news, but at least somewhat more positive, is that the great big hole in the ozone layer seems to be mending. The ozone layer hole was something generated by the use of hydrofluorocarbons in the 60s onwards. This was one of Midgley Jr.'s other mistakes and unfortunately led to their demise, but ignoring that for now, the hole in the ozone layer was a problem. It allowed ultraviolet light to penetrate through, as normally ozone would help to block this. The addition of extra ultraviolet energy led to significantly more heating. Not only does UV light have the issue to do with increasing heating, but it also has a significantly higher contributing effect to things like skin cancer. So you can see why you'd want to avoid this. Within a few years of discovering this great big hole in the ozone layer around 1985, most of the world accepted a process called the Montreal Protocol, which basically required them to phase out the things that would be affecting the ozone layer. Again, mostly talking about hydrofluorocarbons here. These were the things that were used in aerosols. The fact that it's recovering the way it is now is a good sign, and the current estimate is that by 2066, the ozone layer will basically be back to what it was in 1980, and that this is largely recovered to pre-use of these chemicals. Our final news item for you this week is a somewhat more interesting environmental piece of news, primarily because it not only involves nature, but to a certain extent renewables. Specifically, the creation of a living solar cell. Solar technology is not exactly new, it's been around for the better part of 30 years now. We are, however, getting progressively better at developing it, but these are all built on the idea of having to use various metals, which can be very expensive and very hard to process. The idea of using a plant in this case is also not necessarily new. The idea of being able to take a plant, which normally uses chlorophyll to create energy, and use that to then create electricity, is something that's been tried, and often with very limited success. Photosynthesis is something that could theoretically be made to work, but it's hard. That's where the interesting study is, well, interesting. They were able to use a succulent, which is basically a sort of cacti-related plant, by taking an iron anode and putting it in one side of the plant and a platinum cathode into the other. They were able to generate 0.28 volts. This is a tiny amount of energy, admittedly, but the fact that they could do so with just a single leaf is kind of awesome. The trouble you're going to have here is many-fold, but the obvious answer is that if every leaf on the plant requires itself to be wired, you're going to have problems. That's a lot of leaves, a lot of wires, and a lot of material. You may get more power out of it compared to a standard battery or similar, or even compared to a solar cell and a panel, but you're going to need a lot more material and a lot more effort to make them happen. And of course, it's a plant. They don't necessarily live forever. Where you do get deterioration and breakdown of things like solar panels, they are replaceable with relative ease. A plant, not necessarily so. There is one other caveat to this though. During the process, the researchers were able to extract and collect a small amount of hydrogen. Now remember, they did this using a single leaf, so theoretically, you could produce not only electricity, but also hydrogen gas this way. And that could be the difference here, where a panel can only produce electricity, and that after a certain temperature there is a diminishing benefit from it. This could theoretically keep working and keep generating more power, and the hotter the environment gets, the better it is. So you would not only get the benefit of the electricity, but then the hydrogen gas. Downside to this is that it will also need water, so you're adding another consumable rather than a static object that doesn't require any extra materials once it's made. The final and very significant caveat to this is that the experiment may have either only been run for a day, or it is possible that the leaf was only able to function as a solar cell for a single day. In either case, this is very preliminary evidence and it needs a lot more research and work done on it. That's all the news we have for you this week. Thank you for watching. If you found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions you have below.